Greetings, AP Chemistry students. This is Mr. Harper, and the purpose of this recording is to give you guys a brief introduction to how to use Microsoft Excel to do a variety of things. Now, most of what I show you can be done on your graphing calculator using the lists like we've done before, but Microsoft Excel is much more powerful program. It can do a lot more things than your graphing calculator can, and in this case, it's a lot more easy to do that because you're going to have a lot of data points. So I've already got some data here that's in Microsoft Excel, and rest assured, this is completely made-up data and not necessarily going to bear any relevance to what you guys see here in the lab. It's just to give you guys an example, so don't copy what I'm doing, but use it as an example. So we're going to go through the two steps in the data analysis of this lab. In the first case, we're going to make the standard curve, which is going to tell you the relationship between the concentration of crystal violet, which we're symbolizing by CV+, and the absorbance of light at, in this case, 565 nanometers. Now, in class we looked, this is one thing I just would like to say really quick. In class we looked at the absorbance spectrum of crystal violet, and we saw the most strongly absorbed wavelength of light was like 600 nanometers. And so from that, people took a lot, I think in a lot of cases, that they should measure the absorbance at 610 nanometers because that's closer in wavelength to the absorbance maximum. Well, it turns out if you guys look at the data, that it is actually more strongly absorbed at 565 nanometers. And so that would give you a better measurement. If you did do it at 610 nanometers, I would not sweat it. I would use that data and see what kind of results that gives you, and then go from there. Because I think it will also work out that way, just it wouldn't be quite as accurate for determining concentration and that sort of thing at low concentrations because you get smaller absorbance measurements. Okay. So what I have here is some data. So here's my concentrations of crystal violet that I'm using for the preparation of the standard curve. And here's the, in this column here, I have the absorbance measurements that I've made for those different dilutions. And so the first thing I want to do is get a graph of the standard curve and an equation of the best fit regression line. Okay. So to do this in Excel is very easy. What I'm just simply going to do is I'm going to select these values right here, which are going to be my X values, or no, sorry, my Y values, and then here is going to be my X values right there. No, sorry, other way around. These are going to be X, these are going to be Y. And I'm going to go over here and I'm going to press this button that looks like a chart. This is the chart wizard. Now, by the way, this is the 2003 version of Microsoft Office because I am loath to change things that I know. But the new versions of Microsoft Office work very much the same way. There's either going to be a chart button you can press, or if you go to insert, there's going to be an option to add a chart. And so that will do exactly the same thing. So I'm going to press the chart button. What we want here is a scatter plot, like we've been doing in class using the graphing calculator. This is very much the same as using the graphic calculator using lists, okay? So the XY scatter plot, I'm going to say next, okay? And here you can see we have a plot here of my data, okay? And it tells me where this is at. Okay, so the data series are in columns. It shows the data's at. Okay, that looks good, okay? And if you guys click over here on the series tab, it'll tell you that my X values are these right there. Okay, now if you look here on the spreadsheet, this is column A, and then it says $5, whatever. Okay, that means we're starting here in the 5th cell in the A column, going down to the 10th cell. And if you were to go over that way, it would show you that. Same thing here for my Y values. That tells me that we're starting in column B and at cell 5 going to cell 10, and that's what we're going to graph right there. Okay, so if I go to next, I can add some things here like a chart title. So I'm going to say standard curve for crystal violets. No, I'll even use the @ sign to be trendy. 565 nanometers. Okay, on the x-axis, I'm going to say crystal violet, and then I'm going to put my unit there as molarity. And then on my y-axis here, I'm going to write absorbance because that's what I am plotting. Now remember that if you guys made transmittance measurements and are manually transforming that into negative log t and absorbance are the same thing. They just, transmittance is light going through the solution and absorbance is a scale of light that gets absorbed. So I'm going to hit next here, and then that gives me the option to put it in a new sheet or as an object in this sheet. I'm just going to put it right here just so it's next to the data, whatever. Okay, and there's my standard curve. We can, enlarge it whenever and make it, beautify that baby. I like to delete that because it just gets in the way, and I like to kind of clear that area so that isn't all whatever. And just for the sake of clarity, we'll get rid of that guy too. So here's my pretty standard curve, okay? And for this experiment, I want you guys to include a copy of this with your lab report, okay? Now here's my scatter plot. I need the regression line here. That's really what we're after, because that equation is going to tell me the relationship mathematically between the absorbance of the solution and the concentration of the crystal violet that's there. So to get that, again, there's a variety of ways. I'm going to click on that data series, and I can do one of a couple things. I can say insert, and then, no, don't want to do that. Okay, maybe select the data series. I can do some things there. But what I like to do instead is I'll right-click on it. I'll say format data series. No, I don't want to do that. Sorry, cancel slide. Okay, right-click on that and say add trend line. That's going to add a line. And I have an option of doing a variety of different things here. Here we're going to do a linear trend line. I'm going to select options here. So I want to know the equation, so I'm going to click display equation on chart. I want to know the R squared value because that correlates to how linear the line is. I'm going to say display that baby on the chart too. And here I have the option to set the intercept. For this graph, we want the y-intercept to be 0, okay, because at 0 concentration of crystal violet, it should absorb 0 light at 565 nanometers. The reason we have to do the standard curve here on Excel is I don't know how to make a graphing calculator set the y-intercept to be 0. If you do not set the y-intercept to be 0, then you'll get crazy numbers later on. So the y-intercept here has got to be 0. That's why we're doing it like this. Okay. So I'm going to say okay. And there we go. And it's giving me here the equation of my line. Y is equal to, whatever, 30,109 x. Okay, and then R squared is 0.9988. Okay, it ends up being nice linear. And of course, it's nice linear because I made up the data. Okay, so this is an example of, again, how to do this, not exactly what you are going to see in your experiment. Everybody will have slightly different results. Okay, but this is what we need here from the standard curve is the equation of the best fit line. Now, I'm going to take this to do the rest of the data analysis. Okay, part 2 of the experiment, which we are going to be doing on the 29th of January, which is right now, tomorrow, but when you guys are watching this, probably today, okay, is in that part of the experiment, what we're going to do is you're going to make absorbance measurements during the reaction between crystal violet and sodium hydroxide. As the reaction occurs, you guys are going to see a change, right? Because crystal violet, the species that absorbs light at 565 or 610 nanometers, whatever, is being used up in the reaction, okay? Now, in order to determine the order of the reaction, you have to make graphs involving the concentration of this versus time in various forms, like either concentration or 1 over the concentration of crystal violet or a natural log of the concentration of crystal violet. You're not going to have that data directly. You'll have measurements of concentration and time, okay? So we're going to look here at some data that I got the other day, okay? Now, just for the sake of fun here, okay, I measured the absorbance of the crystal violet at 2 different wavelengths here, the 565 nanometers and the 610, and also have the transmittance here, okay? Now, let me show you guys something that's really, okay, so I just write a couple things down here so I don't forget, okay? So at a wavelength of 565 nanometers, the equation of my line, which describes the absorbance, is y is equal to, we said 30,109 times x, which really means, okay, the importance thing here is that this means really absorbance is equal to 30,109 times the concentration of crystal violet in the solution, okay, because that is what x is. So that's what we found, okay. So here's some data. So here I've got time recorded, and then I've got transmittance, the 2 different wavelengths, and absorbance, okay. Now here's the thing. An important thing to keep note of is that when you guys are recording the time, you're going to start, you're going to label on your data that you're recording 0 seconds. Understand that time 0 is the time that you immediately mix the 2 chemicals together and they begin to react. You are not actually going to be measuring the absorbance at that time. So it is not truly time 0. This is just our first data point. Now, This data was actually acquired using an iPad where it measured the sample rate, once every second, whatever. So you're not going to be able to do that. You're actually going to measure it manually. We'll talk about that tomorrow. Okay. But let's say for the sake of argument that the data that you recorded was transmittance instead of absorbance. And we wanted to do a transformation. We can do that really fast. That's why these things are awesome. I'm just going to insert a new row here. I'm going to highlight that by clicking up here at the top. I'm going to say insert, and it was puts a whole new column in there for me. Lovely, right? So, say that I want to make this, I'm going to label this because I like to keep it real straight what I'm doing. Okay, say that I want to make this negative log t, okay, and I'm going to say that this is at, for the sake of argument, 565 nanometers. Now, why I'm showing you guys this is I'm just saying, no, I don't want it to be a formula, whatever, man, okay, it's very picky about your syntax, okay, so say that I had forgotten, instead of measuring absorbance, say that I had measured percent transmittance instead, okay? Say that I wanted to, instead of that, have absorbance, but I only had these numbers right here, okay? What I would do is I could say, okay, I'm going to put a formula here into this cell, and I'm going to say that this is going to be equal to, I want to have this right here as a decimal, so I'm going to say parentheses, that guy right there, divided by a hundo, okay? So that's that as a decimal, but then remember again, I want to make this negative log of that thing. So I'm going to go back here and I'm going to say, okay, well, that's going to be negative log of that right there, okay? Now, yeah, this is really awesome, right? Because I just put in a formula. I'm going to say this cell, what I was going to have here, is equal to the negative log of this guy right here divided by 100. And if I do that, voila, look at that. That is the same thing there as my absorbance. Now, even cooler, I would have to do that for every data point, right? Which is long and tedious and terrible, but there's this option, okay? If you take a look here at this box, how this is highlighted, you see here in the corner how there's that dark little square. If I highlight that, see how that turns into a crosshair? I can left click on this, and then I can drag that down. And this is a command that is known as fill down. What it's going to do is it's going to copy that formula into each of these cells that I am now highlighting, and that's going to tell it to take the negative log of the corresponding data point in the cell a few columns over. And we're going down and going down. Notice here, I took like 500 and some odd data points the other day, and so this would be very tedious to calculate it all by hand, but with the power of spreadsheets, I can just make it fill down. And huzzah, there we go. Now, notice here, this also corresponds exactly to the absorbance measurement I have over there. So either way, it would give me the same thing, okay? Now, here's the thing. Here's my rough data. Here's time, okay, in this column. That's important, so I'm going to make that baby bold, okay? And for the purposes of what I'm showing you, I'm going to look at here at green light absorbance, okay? So there's the important stuff. We could do this with orange light, but we're not going to for right now. Okay, now I did that to show you guys. Now I'm going to take that and delete it so we don't get confused. Okay, so I'm going to delete that. What I really need to make my graphs to evaluate the order of the rate law is I have to have the concentration of crystal violet. Okay, so here's how I'm going to do that. I'm going to make the computer do the work for me. I have to take these absorbance measurements and change that into concentration. Here's how I'm going to do that. First, I'm going to label this guy. I'm going to give this cell a title so I can tell what's down there below. I'm going to say this guy there is going to be the molarity of crystal violet, okay, which is symbolizing as being Cv+. Now, in the cell below, I'm going to tell this thing how to calculate the concentration. You see here that my line says absorbance equals 30,109 times the concentration of crystal violet. Well, just mathematically, right? Crystal violet then would have to be equal to the absorbance value divided by 30,109. So here I'm going to say, to put my formula in, I'm going to highlight the cell. I'm going to say up here, this is equal to the absorbance at that wavelength, which is that guy. And I'm going to say divided by the value of the slope from the regression line equation, which is 30,109. And then I'm going to hit enter. Now, when I do that, this just went through here, and it calculated the concentration of crystal violet at that point in time, which in this case is 1.92 times 10 to the minus fifth power molar, or 19.2 micromolar. Now, notice here, this is a lesser concentration than what I said the stock solution was. I said the stock solution is 25 micromolar, or 2.5 times 10 to the minus fifth molar. That is because between the time it takes for you to mix the crystal violet, the sodium hydroxide, and get it in the cuvette and get it in the colorimeter, the reaction will already have proceeded and the concentration will already have decreased to be less than what it was originally. That is an important thing for you to understand. Okay, so there we go. Now I'm just going to take this baby and I'm going to fill down. I'm going to go faster and faster and faster and faster and faster and faster and faster. And there we go. Okay. So now what I've done is I've gone through here, I've filled down, and this is telling me the concentration at every point in time going down the graph, or going down the list here. Okay. So I now have concentration in this column, and I have time over here. So I can do, as you see, like the similar sort of transformations here, because I want to make 3 graphs. I want to plot concentration versus time, and I want to plot natural log. I'm going to make this bold also. I want to make this baby natural log of the molarity of CV. I might better say apostrophe, okay? Natural log of the molarity of CV plus, okay? And then over here, I'm going to make this baby 1 divided by molarity of CV plus. Oh yeah, you might wonder why I put that apostrophe right there. That's to tell Excel that I'm not putting a formula into that thingy. Okay, so there we go. I'm going to make that bold too because I like to label it. Okay, now in the same way, to do those transformations of the data, I just have to tell it, and this cell, I'm going to say this is equal to, okay, natural log ln of that guy right there, enter, okay, and that there has just found natural log. I'm going to take that baby and fill down, woo, oh, too far. Okay, and like so, and then here again, I'm going to say this is going to be equal to 1 divided by my molarity, enter, and then I'm going to take that baby, and I'm going to fill down. Nope, too far. Nope, too far back again. Okay, and there we go. And now I can make my graphs for those. And just to show you how to do that again, okay? If you're not sure, sure what you're doing really or what you want to graph, okay, so here's another way to do it. I'll just hit my chart button. I'll deselect that. I'll hit chart. I want to make a scatter plot. I'm going to say next. I'm going to say my data series is in columns. And now to go select where that's at, I'm going to hit that guy right there. So to select my X data, I'm just going to go here to time. I'm going to select that guy. I'm going to drag woo, all the way down here and select all my data. Highlight it. I'm holding down the left click button here to select that whole thing. Okay. Then I make my Y list this. Nope, I don't want to do that. Nope, not at all. Shoot. Okay. No, maybe I don't want to do that. Okay. Series is in columns. Okay, series. Yeah, that's where we go. Okay, so I want to add. There we go. Sorry about that. Okay, so I'm going to make that my X data. I don't do this very often, as you guys can tell. But it's useful for you guys to be exposed to this here a little bit because when I went to college, I had to use Excel for some things, and it's always uncomfortable never to have done it when you have to do it for something. Okay, so here's my X data to get the Y values. I'm going to hit that guy there to select my list. Okay, my Y value is going to be here for this graph. I'm going to do the concentration. Okay, there we go. We're going to go back. It's going to be a preview there of the graph. Look at that. We got a whole lot of nice data points. Okay, and then you guys can go in there and do it from there and add your titles and all that sort of thing. I'll let you guys do that, but there we go. There's my graph there, that doohickey. Okay, so that ought to tell you something. There's a free hint for those of you guys who have watched the podcast here. So I wish you guys all luck. In doing this, really only one person from your group needs to do the Excel graphs, but I would like you guys to include with your lab report a copy of each of the graphs so that you can justify the order of the reaction with respect to crystal violet. If you guys have any questions about how to do this specifically, or you need help, or what have you, do come and talk to me, and I will be happy to be of assistance. With that, I hope you guys have a very nice day, and I will talk to you later. Goodbye.